Hey everyone, welcome back to my channel, where we dive into the world of coding and solve some of the most interesting problems out there. Today, we're going to tackle a problem from LeetCode, called minimum element after replacement with digit sum. This is an easy problem, but it's a great way to practice your coding skills and think about how to approach problems in a logical way. So, let's get started and see how we can solve this problem. The problem states that we have an array of integers, and we need to find the minimum element after replacing each element with the sum of its digits. This means that we need to take each number, break it down into its individual digits, and then add those digits up to get a new number. The smallest of these new numbers will be our answer. So, let's think about the intuition behind this problem. Imagine you have a bunch of numbers written on pieces of paper, and you need to replace each number with the sum of its digits. It's kind of like simplifying a complicated math problem into something much simpler. You're taking a complex number and breaking it down into its basic building blocks, which are its digits. By adding up these digits, you're getting a new number that's much simpler and more manageable. This process is like distilling a complex idea down to its essence. Now, let's walk through how we can solve this problem. We need to initialize a variable to keep track of the minimum sum we've seen so far. We'll set this variable to positive infinity, so that any sum we calculate will be smaller than it. Then, we'll iterate through each number in the array. For each number, we'll calculate the sum of its digits by taking the remainder when divided by 10, which gives us the last digit, and adding it to the sum. We'll then remove the last digit by doing integer division by 10, which effectively cuts off the last digit. We'll repeat this process until the number becomes 0. Once we've calculated the sum for a particular number, we'll update our minimum sum variable if the new sum is smaller. Now, let's look at the code that implements this solution. We have a class called solution, with a method called minElement that takes a vector of integers as input. Inside this method, we initialize a variable called min_sum to positive infinity. We then iterate through each number in the input array using a for loop. For each number, we calculate the sum of its digits using a while loop. Inside the while loop, we calculate the remainder of the number when divided by 10 using the modulus operator, which gives us the last digit. We add this digit to the sum, and then we remove the last digit by doing integer division by 10. We repeat this process until the number becomes 0. After calculating the sum for a particular number, we update our min_sum variable if the new sum is smaller. Finally, we return the min_sum variable as our answer. Now, let's think about the complexity of this solution. The time complexity is n*m, where n is the number of elements in the array and m is the average number of digits in each number. This is because for each number, we're performing a while loop to calculate the sum of its digits. The space complexity is 1. Which means the space required does not grow with the size of the input array. This is because we're only using a constant amount of space to store the minimum sum. And that's it, folks. That's how we solve the minimum element after replacement with digit sum problem. I hope you guys learned something new today, and I hope you had fun solving this problem with me. If you did, be sure to like the video, subscribe, and comment your approach below.